Right, we're going to talk about higher order derivatives. And all this is the second, third, fourth, and so on derivatives. So you can really take an unlimited amount, okay? Usually you won't do a very high number unless there's a pattern involved. So let's look at the notation. So for the first derivative, remember there's a couple of different ways to write it with the y prime, f prime, dy dx, the derivative of your function, okay? When we get to applications, the label is meters per second. Now, the second derivative, you put 2 slashes for everything, and then it's derivative of the second function with respect to x twice, okay? And the unit is meters per second or meters per second squared. Third, fourth, and after 4, we really just put the number inside a parenthesis or as the exponent, okay? So, let's try some. For these, if I don't specify it, I just had you find a few. So let's do, this is asking for the third derivative. All right, so use your notation. Our first derivative is a power rule. Then we take the derivative of that and the derivative of that. Okay, and we're done. This one wants the fourth derivative. So if you don't like that notation, you are welcome to change it. But notice we are starting with the first derivative, okay? So our second would be a power rule, and that's what you're typically using these on, or the quicker ones, okay? You won't be doing quotient rules 3 times. That's just too time consuming. Theoretically, you could. Third derivative, another power rule, that goes away, and so our fourth derivative. I don't use my parentheses, it's okay. 120x. All right, we do it a lot for trig because there are patterns with some of the trig functions. So this one's a fourth derivative and we're given the original. So our first is cosine. The derivative of cosine is negative sine. Our third derivative, the derivative of sine is cosine times -1. And our fourth derivative. The derivative of cosine is negative sine times -1 is positive sine. And so we actually start back where we began. Okay, that's not a coincidence. Okay, so let's try this one. Now, if I see a high number like 20, that means eventually there's got to be a pattern. So let's just explore. So our first derivative, e to the u, minus e to the negative u times the derivative of the exponent. So that becomes e to the x minus, that makes it plus, e to the negative x. All right, let's try our second derivative of this. So e to the x plus e to the negative x times a -1, because that's derivative of the exponent. So e to the x minus e to the x. And so what happens is, look, we started out where we began. So this was our second derivative. And so then if I go again, I'm just going to keep doing it. So this will be our third, our fourth, our fifth. And so you'll notice these are all the even derivatives and these are all the odd derivatives. So since that's an even derivative, it's going to equal this. So f to the 20th derivative is e to the x minus e to the x. Patterns are good.